Good afternoon, everyone, from here in Dhaka. So we just had our inaugural session, and we are about to begin session. So the first session is climate extremes. It will be chaired by Professor Dr. Someshwar Das sir, and also co-chaired by Dr. Shamim Hassan Bhuiya sir. So I just have a brief introduction of the chairs and co-chairs, and then I will just let the hosts take over the sessions. So Professor Dr. Someshwar Das sir is joining us from South Asian Meteorological Association, SAMA. He's a very distinguished professor, has many years of services in India Meteorological Department, NCMR WF, India, as well as Central University of Rajasthan, where I happen to be one of his students, did a thesis under him. And also Dr. Shamim Hassan Bhuiya has many years of services at Bangladesh Meteorological Department, and he's also a distinguished meteorologist. So I leave it there for the session chair and co-chair, and to the participants. Thank you from Conference Secretariat. Over to you, both Das sir and Shamim Hassan Bhuiya sir. Thank you.
Okay, thank you very much, Saurabh. Am I audible clearly?
Yes, sir, I can hear you.
Great, very good, very good. So thank you very much for introducing us. Well, I, along with our co-chair, Dr. Shamim Hassan Bhuiya, we welcome all the participants to this very important session on climate extremes, because everybody talks about the extreme weather systems is becoming more and more extremes and things like that. So let us hear from different scientists, participants, that what is the real situation affecting us. Okay, so this is what I would like to say, and then already times are fixed. Every speaker is supposed to talk for about 15 minutes only. So at about 10 minutes, you have to make a presentation, and then about 5 minutes for the discussion. Well, I hand over to Dr.
Do you hear me?
Yeah, Dr. Bhuiya, please. Over to you, Dr. Bhuiya.
Yes, now it is audible. Please, earlier portion we did not listen actually.
Oh, I see. Please increase your speaker's volume, because my mic is not under my control.
Okay, now it is comfortable.
Okay.
Now your audio is now very comfortable.
Very I hope everybody is able to hear. Yeah. So yeah, on to you, Dr. Bhuiya. I've already said my part.
Okay. Thank you, sir. Actually, this topic, severe storms in changing climate, speculations, uncertainty, and reality. This topic is very important due to the global warming and climate change. And nowadays, WMO developed the GFCS, Global Framework for Climate Service. And in this climate service, there are 5 topic is now included, and it is most immediate and most important sector is now included. One is disaster risk reduction, another is health, then water resource management, then renewable energy. These topics are also very important due to climate change. And I think impact-based forecast, this is now very demandable for the society, for the sustainable development of the different national meteorological service. Target should be the impact-based forecast and sector-specific early warning system. So I think that this type of paper will be more important for us for the sustainable development, as well as the combat of the adverse impact of climate change. So I think now, sir, in your hand, we should continue now. Thank you, sir.
Thank you very much, Dr. Bhuiya. So without losing the time, let me share my screen to start the presentation. Okay. So can you see my screen?
Yes, sir.
Okay, great, very good. Just 1 minute. Okay. Well, okay, so in the next 10 to 15 minutes, I'll try to complete this very important topic on severe storms in changing climate, speculations, uncertainty, and the reality. Okay, first of all, I'll talk about the speculations, and then same sequence, I will talk reality, and then the consequences as per the IPCC AR6 report, and finally the summary. Well, let us first see what is the reality, on the other hand. Well, we all know that there is an increase in the global mean temperature by about 1.1 degree as per the IPCC AR6. We also know that we are on the path of exceeding 1.5 degrees centigrade global warming. Melting of glaciers due to warmer temperature is occurring. Arctic sea ice is rapidly diminishing. Sea levels are rising faster today than ever before. There is more carbon dioxide in our atmosphere than at any time in human history. Our remaining carbon budget is tiny. Extreme heat events have become more frequent and severe. 2/3 of extreme events in the last 20 years were influenced by human beings. The changing climate can influence the intensity and frequency of storms. Okay, these are the realities that we know already has been studied and also recorded by IPCC. But the big question is that how and why do we expect the severe thunderstorms, the local severe thunderstorms to change in the greenhouse enhanced atmosphere? Okay, have thunderstorms, tornadoes changed really? How do severe thunderstorms fit into climate? Okay, these are the big questions. Okay, now there are many speculations which are being done about these things by the scientific community. First of all, there is a belief that increase in extreme weather events are due to climate change. Well, to a certain extent, yes, but to a certain extent, it is not so obvious. Okay, the warmer temperatures over time are changing weather patterns and disrupting the usual balance of nature. Okay, this again is a speculation. Okay, we don't know really whether it's really happening like that or not. The warmer world will produce more severe storms. Again, this is also kind of a speculation because what we know today is based upon the climate model integration for next several decades, 20 years, 50 years, 100 years, and so on. Okay, that's what we get from the models about the future. Okay, and the models probably indicate that the warmer world will produce more severe storms. But let us discuss now. In the course of discussion, we will see how confident we are about those things. Okay, in a changing climate, severe storms would cause stronger winds, larger hail size, intense lightning, cloudburst, torrential rains, fatalities of human lives, and big losses of economy in future. This is what is the speculation people have. Okay, so well, this is the thunderstorm. I'm going to skip this, and these are the definitions of the different severities of the nor'westers. In our region, for example, we define the gust wind or a squally wind or light nor'wester, moderate nor'wester, severe nor'wester, tornado, etc., all based upon the strength of the wind speed. Okay, so the question is that are these nor'westers or severe storms going to be more severe, or they are going to be more frequent? What is going to happen in the coming decades, in the next 20, 30, 50, 100 years? Okay, that is the big question. Well, before we try to investigate that, let's see what is the climatology of thunderstorms over the SAARC region, that is the South Asian region. Okay, Well, this is a diagram which shows the characteristics of convection, okay, based upon several years of TRMM data published by House et al. In 2007. This basically tells us about the characteristics of convection, okay, and based upon the TRMM radar, House et al. Found that in the northwestern part of our region, southeastern region, there is a deep convective core, deep convective towers like this one. Then in the central part of South Asia, we have got wide convection upstream, and over the Tibetan plateau, we have deep convective cores, okay. And over the Bay of Bengal and adjoining region, we have got broad stratiform precipitation area, okay. So this is the nature of convection around the southeastern region as found by the TRMM observations and published by House et al. Okay, this is the kind of climatology of the frequency of thunderstorms over the Indian region. Okay, in different seasons. This is for annual. This is for the winter season. This is for the pre-monsoon. This is for the monsoon, and this is for the post-monsoon. Okay, and as you can see that annually, if you see that we have got three maxima. Okay, the prominent one is over the northwestern part of India annually. Okay, these are the frequency of thunderstorm, by the way. Then second one is over the northeastern parts of India, including Bangladesh, Assam, and so on. And also there is a third maxima in the southern region, southern peninsula India. Okay, this is the annual situation. In winter, obviously, we have got less convection over most part of the continent, but then we have got the influence of the western disturbances in the northwestern part of India. So we have got a maxima in the northwestern part of India in the winter season. In the pre-monsoon season, of course, we have got more ferocious, storms, nor'westers, and the prominent of them are in the northeastern part of India, including the Bangladesh. We also have on this northwestern part of India, there is basically the dust storms and so on, and also some maritime convection is there in the southern part of India. That is the pre-monsoon situation. In the monsoon situation also, we have got two maxima, one again over the northwestern part, another one over the northwestern part of the Indian subcontinent. And then over the post-monsoon, we have got again prominent in the southern peninsula because we have got the effects of the northeastern monsoon here. And then we have got some feeble things in the northeastern part and something also a little bit on the northwestern part. This is the climatology of the frequency of the thunderstorm, not talking about the intensity, but just only talking the occurrence and non-occurrence, okay? This is about the monthly frequency of tornadoes compiled based upon the data from 1839 to 1999 of the India Meteorology Department. India Meteorology Department was established more than 150 years ago. Okay, and as per this climatology, the maximum number of tornadoes occur in the month of April, that is the pre-monsoon season, followed by May, and so on. There are the statistics. Okay, I'll quickly these things go, otherwise we'll have lack of time. Then this is the monthly distribution of the hailstorms in India. Okay, this is the red color indicating the moderate hailstorms, and the green color indicating the severe hailstorm. Again, maximum frequency is in the pre-monsoon season. Okay, and this is the monthly distribution of the diurnal variation of the hailstorms in India, and as it shows that the maximum number of hailstorms occurred in the afternoon around 16, 17 local time. Okay, local time, that is 4 o'clock, 5 o'clock local time. Okay, this is what the climatology says. This is the climatology of the lightning. Okay, lightning flash rate density over the Indian region based upon the again data from 1998 to 2013. Okay, recently published by Onassis from 2022 in theoretical and applied climatology. These are our former student at Central University of Rajasthan. Here again, the maximum frequency of lightning is obviously in the month of May, April, May, which is the pre-monsoon season. Okay, and as you know, lightning causes a lot of fatalities nowadays, considered to be one of the biggest disaster. We count all the deaths together now for the entire year. The deaths because of lightning is quite large, right? And this is the trend of the lightning flash rate density over the Indian region from 1996 to 2014, based on that climatology. And what we see is that, well, this is for the December, January, February, the A, this one. This is for the March, April, and May. This is for the June, July, August, and this is for the October, November, December. The four diagrams show 3 monthly, quarterly trend of the lightning, climatology. And as you can see that, the trend shows slight increasing trend of the lightning frequency in the northeastern part of India, including Bangladesh. Okay, maximum trend is there, positive trend. In the pre-monsoon season, that is March, April, and May. Then in June, July, August, maximum lightning trend is occurring in the northwestern part of India. Okay, and again in December season, winter season, September, October, November, we have got here. The maximum trend is somewhere in the central part of India. Okay, so this is the trend of the lightning. That means the trend of the thunderstorms. Okay, this is what is seen by the climatology. Similar climatology we have also got from the other southeastern countries, like we have got from the Bangladesh, then from Nepal, etc. I'm not going to explain these things in detail because otherwise I lose the time, miss the time. Okay, also they have got the thunderstorm climatology from Pakistan, where maximum number of thunderstorms and the storms occur in the northwestern part of Pakistan. Okay, and also similarly from Sri Lanka and Maldives, we have got these climatology of thunderstorms. So this is about the climatology of thunderstorms in our region, that is South Asian region. What about the other parts of the world? Okay, what is the situation there, like in USA, or France, and China? Okay, we define the strength of the nor'wester in our region based upon the strength of the wind. Similarly, they also have a criteria for defining the severe thunderstorms. And let us see what is their criteria. Okay, so according to them, the size of the hail should be at least 1 inch in diameter to be called it as a severe thunderstorm. Okay, the wind speed should be about 50 knots. That means about 58 miles per hour for tornadoes to be termed it as a severe storm. Significant weather, severe weather is defined as 2 inch of hail, size 65 knots of winds, that is hurricane force, and about F2 category tornado. That is called the severe, significantly severe, okay, storm. And these are the reports compiled by many other investigators in different parts of the world, in France and Europe, in Germany, etc. So they are all published. I'm going to see these things. Let's quickly see this diagram. What does it show? This is the US annual tornadoes. Okay, the black one is showing the days per year with at least one tornado of F1 intensity. Okay, a trend from 1954 till compiled till 2014. Okay, and the red curve is showing the number of tornadoes, at least more than 30 or so, in one day. Just in one day, that was tornado. So there are two curves. Now let's see the characteristics of the two curves. The number of tornadoes, at least one tornado per day. If you look at this trend, then this trend is showing a decreasing trend, decreasing. Whereas the clustered tornadoes, like mini tornadoes in one day, this kind of things are increasing with time. That means from 1954 to 2014, the records show that the clustered tornado or mini tornadoes in one day are increasing, whereas one tornado per day trend is decreasing. So like that, we also have got many studies by different authors about the trends of the hail occurrence and their size also by different authors for different reasons. Okay, some say that trends are significant, some say that trends are not significant, and so on. This is for the France and Italy, let us say the hail data. Okay, the record from 1988 till 2008 shows that there is a slight decreasing trend of the occurrence of the hailstorm. Okay, but the intensity of the hailstorm, the trend is slightly increasing. Okay, the frequency is decreasing, whereas the trend of the intensity is increasing, and so also the kinetic energy of the updrafts. Okay, this trend also shows increasing trend. Okay, So what is the summary of the hail observation? According to all the studies, if we just try to synthesize, it shows that there is a little change to slight decrease in the occurrence of the hailstorms. There is a small decrease in mean size of the hails, but increase in the kinetic energy of the hail falls. Okay, it's because they start with a slightly larger hail at the beginning of the fall. They melt more because of the higher freezing level height, and it leaves distribution shifted toward the larger sizes of the hail. Okay. But does it extend to larger sizes? The same question. Now, what are before investigating that? Let's see what are the ingredients for severe thunderstorms or supercells. The point is that, I mean, in the global models, in the climate models, if you try to identify the storms, it is very, very difficult because the resolution of the model is quite coarser compared to the resolution of the or scale of the storms themselves. Okay, generally, typically, as you know, that typical scale of the convective cloud is about 1 to 10 kilometers. But most of the global models or climate models specifically is run at a coarser resolution than that. So if we cannot identify the thunderstorms clearly in the climate model, the question is, can we at least identify the formation or the environment conducive for the formation of the thunderstorms? So let's see that. Okay. For thunderstorms, of course, we know that there should be low level warm air. Okay. There should be mid-level, about 2 to 10 kilometers above the ground, relatively cold and dry air. Something should be there to lift the warm moisture, that is, instability should be there in the atmosphere. Okay. And combine the first two to get the energy available for the storm. Okay, that is the cape of draft speed, which is given by the square root of the 2 times of the cape. So if we cannot identify the thunderstorm directly from the climate models, probably we can try to investigate the environment around the grid points, which could be conducive for the formation of thunderstorm. What about their organization or the changing of the shape of the supercell into a rotation, kind of rotating storms or tornadoes? Okay, and for that, we know that the wind shear is very, very important. Winds that increase and change direction with height about lowest few kilometer wind shear, I mean that is 0 to 6 kilometer, is considered to be very, very important indicator for the formation of the tornadoes. Okay, and also from the equator to surface and westward and aloft. Okay, these are the indications. So if we cannot directly predict or identify the formation of the tornadoes or severe thunderstorms in the next 50 years or 100 years, at least now we can try to identify the environment conducive for the formation of those storms. Okay, this is the global distribution of the mean annual tornadoes. Okay, from 58 to 1999. Well, as you know that the maximum tornadoes in the world occurs in the mid United States, Oklahoma, Nebraska area. Okay, in our region, this is in India, Bangladesh. Bangladesh also we have got tornadoes, some tornadoes also sometimes recorded also reported in the northeastern part of India. So this is what the global distribution of tornadoes state. Similarly, the satellite estimates of the hail globally, if you look at then we have got the pockets of maximum hailstorms occurring in USA, in Africa, also our region. Okay, we look at try to analyze the importance of the shear. Then we know that big tornado years typically have hail as dominant non-tornadic event and having the predominant shear. The intensity of tornado hail increases with increasing shear. So what will happen in the future? Okay, what will happen in the future? Mean expected changes are likely to be the cape will go up because of the warming, and also because of the warming, the moisture content of the air, also moisture holding capacity of the air increases. So it is related to the heat and the moisture. Okay, shear goes down because decrease in equator to pole gradient takes place. The climate model simulations indicate that look at favorable conditions statistical modeling. Okay, concentrate on changes in model board. So the point is, these are the indicators. Okay, from the global climate models, if we try to analyze the results for the next several decades in the future. Now let's see some trend over the United States. For example, of the tornadoes and I mean all these, Sear and the Cape and so on like that. So we just try to divide because tornadoes occur mostly in the USA every year. Hundreds of tornadoes occur. So now people have tried to investigate how is the trend over there, and they try to divide the US, different region like the northern Great Plains, southern Great Plains, the Midwestern, the southeastern part, the northeastern part, and so on. Okay, and these are the trends.
I would like to request sir to finish your presentation.
Okay, okay, great. Thank you so much for reminding me. Well, I'll quickly skip all these things, but anyway, these are the trends of the updraft, the shear, and the combinations, and so on. Okay, and these are the kind of model output for the climate scenario RCP 8.5 versus the historical. I will not explain these things because now I'm going to lose time. Time is up almost. So what is the model summary? The energy term increases in all regions. Okay, shear term decreases. Overall, more environment favorable for severe storms. Well, is shown indicated by some of the models. So how do we look at long-time series? We need to have new tools and for the 21st century real analysis, surface pressure, mostly the SST, etc. Okay, and I'm going to skip these things. They are the analysis of the number of severe storms in the warm months, 10 coldest, 10 warmest months and 10 coldest ones, and so on. I'm going to skip these things. And also whether there's a shift in the region of the formation of tornadoes. Those are the things which are shown here, and also whether there is also a shift in the time for the formation. So I'm going to skip all these things. So the closing thoughts are the applicability, whether the applicability of US is there to the rest of the world, like whether thermodynamics dominated by the boundary layer and moisture is also shown everywhere in the world. All locations may not show the same. The improved modeling need to improve environment event relationships for improved modeling, higher resolution, of course, better analysis we need, and increased use of high resolution models. So those things are required. Tornadoes appear to be more variable in the climate model outputs, like fewer days, but more outburst days and things like that. So what are the uncertainties? Okay, the uncertainties are like there in the physics and dynamics of the understanding of the severe storms, and also same for the model, uncertainties in the design and accuracy of the weather and climate models, uncertainties in the model projections in changing climate, uncertainties in the historical observations at the storm scales. Okay, so the consequences as per the IPCC AR6 report say that while the climate change is a reality, its various impacts on the nature is uncertain. Well, I directly go on to the impact on the severe thunderstorm because these are for the tropical cyclones. I mean, as you have seen that I've just focused on the severe storms, not on the tropical cyclones, although they are also tropical storms, but I'm more concentrating on the local severe storms like nor'westers and dust storms and hailstorms and so on. So let's jump on directly. What is the IPCC AR6 report about the local severe storm? And it says that probably, as per the model indication, future wind speed changes are expected to be small for the IPCC, and there is a low confidence in past trends and characteristics of the severe convective storms, such as hail and severe winds, beyond an increase in precipitation rate. So note this: there is a low confidence. Okay, low confidence. Now, as per the IPCC report about the severe convective storms, now what is going to happen in the future in the next several decades? In next 100 years or so, such as hail and severe winds. Okay, so they are the consequences as per the IPCC AR6. And so finally, summary is that the link between local severe storms, tornadoes, and climate change is currently not fully understood. As such, challenges remain that prevent clear attribution due to limited data collections, high annual variability, and difficulty in modeling key physical elements that help local severe storms and tornadoes form as well as directly modeling them due to their small sizes. Phenomena associated with severe storm, that is large hail greater than 2 centimeter size, damaging wind that is more than 90 km per hour, and tornadoes pose a globally threat. Yet there are limitations of the past records for assessing the trends. Okay, as there are limitations in directly simulating the nature of severe storms due to climate change, many scientists have used proxy methods. As I said, explained earlier, this is the environment, the conducive environment condition for the formation of these storms, for assessment using the environmental conditions and or conditions favorable to the development of the thunderstorms. So these are the summary. The response of severe thunderstorms to a changing climate is rapidly growing area of research. Okay, so that's all from my side. Thank you so much for your presence for listening. Thank you so much. Either we can take the question now or we can take the question at the end of all the presentation. Whatever, Dr. Bhuya, whatever you suggest.
Actually, we are running behind the schedule. So I think accumulated question, please write down the question. And then at the end of the session, we can summarize and we can ask some question.
Great.
So we can go for the second presentation. And as you know that the session will continue, another second session will continue immediate after this session. So please.
I have to stop sharing my screen. Okay. So who is the next presenter for the program?
Characteristics in
From
Bangladesh.
Professor Dr. Masashi Kikuchi.
Yeah.
Right?
Kikuchi.
Kikuchi. Yeah.
University.
Yeah.
Thank you.
Professor Kikuchi is from University of Tokyo, Japan, and he's going to present on rainfall characteristics in Bangladesh using more than 100 years of record. Professor Kikuchi, please.
Thank you very much, Chairman. So can you hear me?
Yeah, you can.
Okay. Thank you very much for the invite me to this session. So today I'd like to, provide some information about rainfall characteristic in Bangladesh in not future, but historical, using a historical record. Yeah, so for the actually our team leader, so Professor Hayashi, and also the Professor Matsumoto, Jun Matsumoto, they are tried to rescue the old data from the not only the department but other, for example, the Indian library or something like that, because the Bangladesh is was the have a observation based by the England. So at that time, they already start the observation in 19th century. So the rainfall phenomena actually it's very important, So not in Bangladesh but in India, Meghalaya states. So the very famous station to have a great amount of the rainfall, around 15,000 millimeter per year. Average. So our team is interested in this phenomena during the 20 years or something like that. So the IMD, Indian Meteorological Department, already provide the 100-year data set for the daily, but it's not including the Bangladesh and the Pakistan. So in that sense, so for us, actually the Bangladesh Meteorological Department has a data from the 1950. So that when we consider about the climate change or such kind of related issues, so what happened? It should know what happened in 100 years ago or something like that. So that we already done the data rescue from all the data from the IITM in Pune, in India. So, and we constructed more than 100 years rainfall record in some station in Bangladesh. Yeah, actually, before the 1950, the station number is not so much. So in that sense, we can have to select the small station numbers, but it's useful, I guess. So using this data, so we try to analyze the data, rainfall characteristic, and it's changed from that period and to now, current situation. So some of you know, so already previous studies, Endo et al. 2015, they use the 15 years daily rainfall record in Bangladesh. So at that time, he used these 13 indices like this. Yeah, this one. So at that time, he used 12 stations in Bangladesh like this. And our studies, so we also try to use the as much as possible. So we select, actually we can use the 23 station, but through the statistic test, so we choose the 15 stations in the Bangladesh. You can see the right-hand side. So and we analyze the rainfall phenomena using the 1260 years record. Yeah, actually, in 1950s and in 1970s, this period is the independence war. So at that time, the many missing the data is there, but still we can use through the statistic test. And we use the same, almost same indices like this, and we try to divide into the pre-monsoon season, monsoon season, and post-monsoon season, like this period. So we use the 126 years old years record, and the data rescue is this about 60 years, and Endo et al. From the BMD, this is about 60 years, and fortunately we can get the data set from the BMD, recent data set about 8 years. Then we use the 126 years data set. So this is the result. So this is an annual aspect of the long-term change. So you can see for example, the R03 millimeter means here number of the days, years, or season with the precipitation amount 1 millimeter to 3 millimeter. So so you can see that most of the station show the positive, the increasing. This is consistent with the Endo et al. 2015. And RX 1 day or something like that. This is here, so annual maximum 1 day precipitation or consecutive 5 days precipitation. So this is you can see this part. It's not so strong, but here are some one or two stations strongly show the increase of that indices. But in Endo et al. 2015, they said decreasing. So that it's opposite signal. And R10 means heavy precipitation days, 10 over 10 millimeter, over 20 millimeter, over 50 millimeter. So you can see that here, this 3 part. Yeah, one station or 2 station has some signal, but it's not so significant. But you can see this is a signal in each station. So for example, you can see some characteristics because yeah, actually here it's not consistent, but for example, from the here, northern part or central part is a decrease, and the southern part is sometimes increase. So some indices show that this kind of the signal. So it means that maybe it's shift of the ITCG or something like that. And this is a result of the seasonal signals. So yeah, for example, in the pre-monsoon season, the small rainfall increasing, but strong rainfall is not so significant. And post-monsoon season, it's not so significant, but some indices, 5 indices, increasing. For example, small rainfall at the same time, the strong rainfall also increasing, some 3 stations or 4 stations or something like that. And this is a characteristic of the change of the, yeah, you know, the maybe this kind of the analysis. So the not how to say, it's not how to say simple, not simple. I mean sometimes the signal is positive and sometimes signal is negative or something like that. So the from this result, so you can see the recent 10 years or something like that. The weak rainfall is significantly decreasing. So this is yeah, actually it's not how to say, very preliminary result, but it's very interesting point, I guess. So I'd like to conclude. So actually generally our result matched with the previous research, means the Endo et al. 2015, and actually we can find the significant change detected by the due to the recent rainfall characteristic change, but it's not to the changes of the beginning of the observation period. So that means that maybe the climate change may be significant. And the trends show the spatial characteristics, both rainfall amount and the rainfall intensity, is increasing mainly in the southern part of the Bangladesh. So that means maybe, yeah, of course, we need some more additional analysis, but maybe we can say the more active ITCG could move southward. And that there are different changing trend among the seasons. So it's also very, for me, very interesting. So when we combine the long-term wind or temperature data, like a synoptic data set, maybe we can define the monsoon onset or something like that. So it's also interesting. Maybe we can find the interest point. Yeah, that's all. Thank you very much. Professor Das, maybe it's muted.
Thank you.
Yeah.
Sorry, it was mute. Well, thank you so much, Professor Kikuchi, for a very interesting presentation. The questions are supposed to be asked at the end, but please do write the questions on the chat box so that we'll take up questions at the end, and also write the name of the speaker to whom the question is directed. Okay, so thank you so much once again. The next speaker as per the program is who is the next speaker? Well, Dr. Bhavani S. Mohanty from Central University of Tamil Nadu, India. Dr. Bhavani, are you there? Dr. Bhavani, are you there? She's not responding.
I think, so just to interrupt, I think Dr. Mohanty is probably not joining. So in that aspect, so can you hear me? Network.
Your voice is not audible. Breaking something. I can't hear you. So is he not there? Bhavani, if he not there, we can move on to the next one.
Sir, I can just since it's in the agenda, I just want to keep it in the discussion. He has at least submitted his abstract, so I just going through the abstract and then we can move on to the next presenter, if you allow.
Yeah, exactly. Yeah.
Okay,
Sure. We can go on to the next. Yeah.
Okay, sir. So the title was a study.
The next one.
Sir, I was saying that since it's in the agenda, I would like to continue for Dr. Bhavani, and then we can move on to the next presenter.
I mean, is he there to present?
No, he's not there, but his abstract is with us. So I'm just reading out the abstract for everyone to just listen.
Oh, I see. Okay. So, okay. I mean, she has said that she will not come, is it?
I think he's not joining, probably.
All right. Okay. So then you can quickly read the abstract.
Sure, sir. Fine. Sure, sir. So I think I have shared my screen where you can see the abstract. So the title was a study on thunderstorm days, pattern of twin city of Odisha. So it's written that the two highest populous city of Odisha is named as twin cities, Cuttack and Bhubaneswar. Thunderstorms are one of the most hazardous climatic phenomenon, which is responsible for adverse losses in agriculture and infrastructure. So in this paper, thunderstorms days obtained in two cities of Odisha since more than 5 decades, 1969 to 2019, are being analyzed. The Man-Kendall and Spearman's row test is applied for calculating trend in thunderstorm days at the spatiotemporal scale. It is known that El Nino and La Nina are well associated with significant atmospheric anomalies at many places around the world. So an attempt is made in this paper to analyze the variability in thunderstorm days for the same period. The correlation coefficient of the time series of seasonal and annual thunderstorm frequencies with rainfall and minimum and maximum temperature have been computed. The graphical representation of data is also given. The distribution of frequencies of normal thunderstorms days over cities is also shown in the form of map. So that's just a brief go through on behalf of Dr. Bhavanti. I think we can move on to the next presenter if you allow her. Over to you, sir.
Okay. Thank you very much, Saurabh, for reading out the paper. We move on to the next paper, and that is by, who is the next one? Just a minute. Yeah, it is by Dr. Saila Akhtar. Bangladesh, Republic of People's Republic of Bangladesh.
Yes, I'm here. Can you hear me?
Great. Thank you so much. So, please, your title is Upper Oceanic Response to the Super Cyclonic Storm Amphan in the Northern Bay of Bengal from Rome's model. Dr. Saila, please.
My slide is clear?
Yes, we can see it. Thank you.
Respected chair and co-chair of this session and honorable convener of the International Conference of Climate Change 2022 and scientists from different parts of the world. Welcome and very good afternoon from Bangladesh. Me Saila Akhtar from working for the Government of People's Republic of Bangladesh. Here I will present the upper oceanic response due to the super cyclonic storm Amphan in the Northern Bay of Bengal using the ocean model ROMS. Here is the outline of my presentation. At first, I will cover the background and motivation, data methodology, and briefly talk about my model setup, and then simulation for the cyclone Amphan. This is my study area, which contains the world's fourth largest river, GBM, and also there are some small and big rivers adjacent to this bay, which keeps the bay fresher all the year round, along with the monsoonal precipitation also aid to keep this bay fresher. And this unique this freshwater dominant basin and presence of the freshwater keep this bay unique than other parts of the world. This bay also experiences the semi-reversal monsoonal wind system, and besides the local wind, the remote wind also have influence over this bay, which is called requisite from equatorial Indian Ocean. As this bay lies in the subtropical area, the SST remains high all the year round with two peaks during spring and autumn, and surface salinity remains low from summer to early winter. This bay, in the Bay of Bengal, is very prone to tropical cyclone. Here in my study, I am considering the super cyclonic Eastern Amphan, which originated at rivers in the Bay of Bengal during 16 to 20 high windy speed since cyclone 1999 and causes huge casualties both in Bangladesh and in India. But it is to be noted that advantage condition cannot only intensify a tropical cyclone. Rather, as the interaction also have dominant influence over the formation and intensification of a tropical cyclone. So in this study, I will see the oceanic response due to the tropical cyclone Amphan and the mechanism of the oceanic response. But the Bay of Bengal, especially the northern part, is lack of observational data. Only few bore satellite data are options. So to observe the response of different oceanic process, a high resolution ocean model is very important. The objective of this study is to investigate the cyclonic response utilizing a high resolution regional ocean model. In my study, I have used the fruit and buoy data, reanalysis data, and satellite data. And 1 degree decrease in temperature is considered as the definition for isothermal layer depth, and 0.2 density criteria is adopted to define the mixed layer depth. And scale, root mean square error, standard deviation also are also calculated to observe the accuracy of the model. Here I have defined the season food season, winter, spring, summer, and autumn, following two prominent scientists, Thata Dilatel and Navakar and Kumaratel. This is my model bathymetry of the ROMS model, and the bathymetry data comes from ETOPO1 data, and I have used the global ocean forecasting system FIOCOM data as initial and boundary condition, and the ERA 5 hourly data for the atmospheric field. And my model resolution is 1/30 for the horizontal resolution, that is about 4 kilometers, and 50 vertical layers. And here I have used considered 11 major rivers through 15 points. You can see that the model temperature and salinity become stable after 5 to 6 years. And this is the model validation part. I will briefly talk about the validation. And we see that this is the observational data, and this is my model data, model output data. And to see that the monthly variation of SST is followed by my model, and spatial distribution is also followed with the low bias, 0.5 degrees Celsius, and vertical temperature structure is also followed with accuracy with RMSE from 0.3 to 0.8. And about the surface salinity, we also see that the monthly variation is well captured, and the salinity structure is also well captured. But the at the mouth of the river, the accuracy is lower, and this is obvious, maybe due to the adoption of insufficient river data. As you know, in this area, the accurate river data is not available. And my model also have captured the prominent circulation pattern of this bay. And in the Northern Bay of Bengal, we know that the current circulation pattern follow the wind pattern, and also the freshwater direction of freshwater plume followed by the surface circulation. And my model has captured this. And about the mixed layer depth, isothermal layer depth and BLT model has well captured. From this part, I want to conclude that a high resolution erosional model is set up for the Northern Bay of Bengal, and the prominent feature of this bay is all captured by my model. This is the SST on the very severe cyclone day, 19th May 2020. And this SST data is from the satellite data MWIR. And we see the huge cooling, and this is the path of cyclone Amphan. The black dot field line at the indicates the hourly variation of cyclone path. And here the depression, deep depression, cyclonic storm, all are different, follow the Saffir-Simpson scale. And in my study area, there are two buoys, Rama buoys at 12 degree north and 15 degree north. And during the cyclone period, there are also a single float was present. This is the idea of the Argo float. Here I will talk about the upward response due to the cyclone Amphan. And this is the atmospheric parameter at the Rama buoy position 12. So that this is the daily variation of a different atmospheric parameter. And we see that before the formation of depression, the air temperature was very high, but just the formation of after the formation of cyclone, the sea level pressure got concave shape and huge rainfall occurred just before the intensification of cyclone, and wind speed become also very high. Here, these figures is also for the Rama 12 degree north position, and model output is the blue color, and the Rama buoy data, observation data is the black color data. So we see that the model followed the Rama buoy data very finely, and on the very high SST just before the formation of cyclone, it is about 31.5 degrees Celsius, and the SST dropped about 3 degrees Celsius at 12 degree north. And the cooling continues till the end of the month. And this is the daily variation, it is to be noted, from May 1 to 30. And we see that due to the high windy speed, the mixing occurred, and MLD, the mixed layer depth, become deeper during the cyclone. Here is the spatial distribution of different oceanic parameters comes from the model output, and it is the anomaly just before and after the cyclone. And to see that the impact of cyclone occurred on the right side of the cyclone track, and we know that in the northern hemisphere, the impact of cyclone occurred on the right side of the cyclone track, and my model captured it. And we see that maximum drop in SST 4 degrees Celsius, and surface salinity increased by 0.4 PSU. And MLD become deeper, and ILD also become deeper on the right side of the cyclone track. I have also compared this anomaly in different parameter, oceanic parameter, and compared it with the single Argo fluid data. This fluid was present just also in before and after the cyclone in this bay. So we see that the model output have followed the Argo very nicely. That SST dropped in Argo about 0.4, and model is also about 0.4. So we can see from this part, the response of cyclonic response is well captured by my model. Here we'll talk about the mechanism of oceanic process. This is the Ekman pumping velocity. The positive Ekman pumping velocity represent the upwelling. That is upwelling the colder subsurface water to the surface that cools the SST and reduce the intensity of the cyclone. And we see that the Ekman pumping velocity follow the cyclonic path very nicely. And the modeled vertical velocity, that is also follow the cyclone path very nicely. So, and that cools the surface temperature. Here in the due to the cyclone, we see the two significant modification in the surface circulation, that is strong northward current on the right side of the cyclone track, and the intensification of pre-existing cyclonic eddies. So due to the intensification of a pre-existing cyclonic eddies causes reduction of sea level anomaly, and low sea level anomaly contribute to the significant SST cooling. Here I have considered this box to see that changes in temperature profile, and we see that temperature was higher just before the cyclone, MLD was shallower, but during the cyclone it dropped and the MLD get deeper. And this is the boxer-based mixed layer heat budget. This mixed layer heat budget is calculated for this box. And here the black color is the assisted tendency. We see the cooling tendency, and we see that this cooling tendency is dominantly controlled by the horizontal aberration term, the blue color, green color. So from my
Dr.
study,
Shaila,
I want to conclude
you
that
have
yes,
more than you have 3 minutes more.
yeah, I will conclude very shortly. And from this part, from my study, I want to conclude that upwelling response in the northern Bay of Bengal due to the tropical cyclone. Ampan is well captured by the regional model. Extremely high SST and deep ILD were the main triggering factor for the formation of tropical cyclone Ampan. And prolonged SST cooling occurs. It is about 4 degrees Celsius, and increased sea surface salinity also occurred on the right side of the cyclone track. And I want to say that horizontal aberration and vertical entrainment term did pronounced cooling in the mixed layer. Thank you all. Thank you all for me. Thank you all to hear me. Yeah, respected chair, I'm done.
Okay.
That is all from my part.
Thank you very much, Dr. Shaila, for your nice presentation. Now the second presentation is, this is actually fourth presentation. Next presentation is characteristics of rainfall and atmospheric condition during the heavy rainfall event on 14 to 16 June 2022 in the southern Meghalaya Plateau, and it will be presented by the Professor Dr. Murata, Kochi University, Japan. Your time is 15 minutes.
Dr. Stella, can you stop sharing your screen, please? Yeah, thank you. I'm sorry, I was interrupted for 5 minutes. Some internet problem was there. I don't know whether it was from my side or from the conference side, but I could not hear the last 5 minutes. Anyway, so Dr. Murata, please, yeah.
Murata-san, yes, your screen is now available.
Sorry.
Thank you. You can start.
Okay. What? ちっちゃい？どれだっけ？見えないんだけど。ああ、そっか。どれかするんだよね。あ、これでいい。あれ？これ。タスクバーの表示して。これになってるな。わかんないなぁ。これがね、重なってるからよくわからん。なんか2つ出ちゃってるね。これでいい。Thank you for waiting. So, my name is Fumie Murata from Kochi University, Japan. I'd like to talk about the characteristics of rainfall and atmospheric conditions during the heavy rainfall event on 14th and 16th June 2022. In the southern slope, southern Meghalaya Plateau. Okay. So, the 14th to 16th June this year, the Cherrapunji, the heaviest rainfall station in Meghalaya, had a record of 24-hour rainfall. It was around 1,000 millimeter in 24 hours. And the 3 days rainfall also very large. It was it was 500 millimeter. So, and in the southern part, in northeast Bangladesh, the downstream area of Cherrapunji had severely submerged and heavy submerged due to the flash floods. So I would like to show, to describe this event using our observational data in Cherrapunji and others, and also investigate the detectability of the heavy rainfall event by the remote sensing data which can obtain in Bangladesh. The data used in this study is an automatic weather station by Sara WXT 520 in Cherrapunji, and an optical disdrometer Possible 2 in Siret BMD office, and GSMAP MVK dataset, and Bangladesh Air Force radar image, and ERA 5 reanalysis data. This is geopotential height. The color of the figure is the geopotential height, and the vector is horizontal wind on at 00 UTC on 16th June 2022 by ERA 5 reanalysis data. Is a lower troposphere, we can see the southerly wind converges into Bangladesh, and in the middle, around 850 hectopascal level and 700 hectopascal, we can see westerly wind is dominant. And at upper troposphere, high pressure system is covered over northern India and Bangladesh. This the upper right panel shows the daily rainfall in Cherrapunji in June 2022, and we can see the extreme rainfall occurred 14th and 16th June, but other period, not sometimes it's 300, but only 3 days are extreme. And lower two figures are time height cross section of zonal and meridional wind in the upper stream region. And you can see the southerly, the lower tropospheric southerly is intensified, and the upper troposphere is northerly. And in the zonal wind, the westerly wind is dominant from near surface to the upper troposphere.
Professor Murata, please unmute.
Sorry. You didn't hear me.
No, just the previous slide. We didn't hear you. Just
okay. Now you can hear. Okay.
Yes. Yes,
okay.
you are audible. You are good.
Thank you. So we can see the very clear diurnal variation in this rainfall variation, and rainfall intensified in the night time. And this is the observational result of automatic weather station, but I'll skip it. And this is the densitometer data at the BMD Siret, Bangladesh. And in BMD Siret, the rainfall, daily rainfall of 60 millimeters, 67 millimeter, and 100 millimeter occurred in the same period, but it was the difference of the rainfall was too much. And also the daily, the diurnal variation of rainfall also it's very different. So in Siret, the nocturnal the diurnal variation is not so dominant. And recently we can see the radar image from Bangladesh Air Force radar, and also we use the GSMAP MVK data set to see the horizontal distribution of precipitation and check the detectability of the heavy rainfall. This is a radar image before the onset of the heavy rainfall, and we can see some precipitation, intense precipitation developed around the southern Meghalaya Plateau by the BAF radar. But the GSMAP data is not so cannot see the heavier rainfall. This is after the onset of the after onset of the heavy rainfall on 14th June, and BF radar shows some intense precipitation, but small convection at the southern slope of the Meghalaya, and GSMAP also show some convections, but not so heavy. And this is 15th June, before the onset of the heavy rainfall. And in that case, we cannot see not so much rainfall in the before the onset. But in GSMAP data, we can see the strong convection developed just northern part of the Cherrapunji.
Murata-san, you have maximum 2 minutes to finish.
Oh, okay. And after the onset of the heavy rainfall on 15th June, we can see the heavy rainfall in GSMAP data, but at BF radar, we cannot see so heavier rainfall. And 16th June, we can see the heavier rainfalls over the Bangladesh plain. And after the onset of the rainfall, these heavier rainfall moved to the southern slope of the Meghalaya. And this is the reliability flag of GS map. And we see the reliability flag, it was low on 14th June. But 15th and 16th June, the reliability is good. So this is a summary of my presentation. The heavy rainfall event in June 2022, Cherrapunji and Mawsynram observed around 1,000 millimeter rainfall in 24-hour rainfall and 2,500 millimeter rainfall in 3-day rainfall was observed. And the lower tropospheric southerly wind was intensified and the zonal wind zonal wind component was westerly from near ground to tropospheric level. And the lower tropospheric low pressure area in the northern India was rather weak, and the upper tropospheric high pressure area covered over the northern India. The diurnal variation of rainfall was dominant in the heavy rainfall event. Rainfall intensified in the night time. And BAF Bangladesh Air Force radar captured the heavy rainfall event as a rainfall area, which embedded small intense convections. But sometimes it failed to detect intense rainfalls occurred on especially 15th June. And GS map captured the onset of rainfall in the southern Meghalaya properly when the data reliability was high. But the quantitative estimation of rainfall was still difficult. That's all. Yeah, thank you so much. Okay, my presentation was finished. You can hear.
Unmute, sir. That's the unmute here.
なんて。あ、そっか。
That's sir. Please unmute your computer. We are not hearing you.
I'm sorry, it gets muted automatically itself. Okay, thank you very much. Am I audible now? Am I audible now? Can you hear me now?
Yes, yes, you are.
Yes, I can hear.
Wait.
Yes,
Thank you so much, Professor Murata, for very interesting presentation. I'm sorry for the
Yes,
interruption.
thank you very
So
much.
anyway, questions will be at the end of all the presentations. So please close your screen and sharing your screen, and then we'll go for the next presentation. The next presentation is from Mr. Bhupendra Bahadur Singh from IITM Pune, Indian Institute of Tropical Meteorology, Pune. Is Dr. Bhupendra Bahadur present here?
Yes, sir. Hello, am I audible?
Yeah, I can hear you. You can hear
Yeah.
me.
Good afternoon, sir.
Good afternoon. Okay, so you're going to present on relation between rainfall and soil moisture variability during dry and wet streams of our core monsoon zone of India, right?
Yes.
So please start. Yeah, you have got 10 minutes presentation.
Yeah.
5 minutes discussion.
Sure. So let me share my screen. So is it visible?
Yeah, it's coming up. Yes. Thank
Yeah.
you.
So now is it visible in full screen?
Yes.
Yeah. Okay. So good afternoon to everyone, and let me thank the organizers and the session chairs for this opportunity. So I am Bhupendra Bahadur Singh. I work at the Center for Climate Change Research, IITM Pune. So today I would be speaking on a relation between rainfall and soil moisture variability, taking an example from deficit and excess seasons over the core monsoon zone of India. So here I would be discussing the results mainly from the perspective of the deficit season in 2015 and the excess season of 2019. But of course, this can be extended to a larger period when we received excess or deficit seasons. So here are my collaborators, Dr. Madhusudan, Dr. Milind Majumdar, Dr. Naresh, Dr. Mangesh, and Dr. R. Krishnan. So I will quickly go to the outline of my talk. So I would be discussing briefly about the soil moisture and its important in climate variability and what are the existing knowledge or gaps, and then I will go to data and resources. And then I would be discussing the main results from the analysis which we have carried, followed by the concluding remarks. So yeah, so soil moisture in the Earth system. Typically in the layman's term, if we say the soil moisture is nothing but the total amount of water, including the water vapor in soil, which typically resides in the pores of the soil. And of course, you can represent it in terms of volume or weight by the measurements which you can get it from in situ observations or remote sensing platforms like through satellite, or even the recent developments through the cosmic ray soil moisture observation system. One such system is there, headed by Dr. Milind Majumdar, is in IITM Pune. And again, if you see on the right hand side in this figure here, so whether my cursor is visible?
Yeah.
Okay. Yeah. So if you see the Earth system as a whole, so there are different components like the atmosphere, hydrosphere, cryosphere, biosphere, and lithosphere, that is the land surface. So there are different components which are in constant interactions between them is going on. So at the equilibrium stage, you see there are multiple feedbacks, there are different processes that are kind of interlinked with each other. So in that, if you see the land surface of the lithosphere, so that is there the soil moisture comes into picture. So if you have to measure soil moisture, so that measurement helps in understanding the overall hydrological cycle and how it can affect the local and regional weather and climate. And it is also considered as a good response of the land surface to atmosphere by the partitioning of rainfall into runoff and the infiltration. And of course, it affects the surface energy partitioning. We will come to that. So the near surface soil moisture estimations helps us to better understand the estimation of surface energy budget, which is again an active area of research because it is where we have the least amount of observations, and we need more and more observations to have better estimate of the near surface fluxes. So this is a simple schematic of land water balance and the land energy balance for a given surface soil layer. So I will not go into details here. So these are all introductory things. So the precipitation is distributed into evapotranspiration and the other components, and also similarly the incoming short wave is again a partition into sensible heat, latent heat, and the ground heat flux, and so on. So if you see these images and the previous information which I just now shared, so soil moisture not only regulates the partitioning of net radiation into sensible, latent, and ground heat flux, and also the surface heat exchange, but it also helps in partitioning of precipitation into evaporation, infiltration, and runoff. So it is where it is playing a major role in energy partitioning as well as in the hydrological cycle. So of course, the level of soil moisture will depend on several factors, including the meteorological conditions and which type of soil or associated vegetation we are considering. So again, I will just quickly go through it. So this is, if we say surface soil moisture, so this is in the upper few centimeters. And if you go deeper, it is usually termed as the root zone soil moisture. So it is one of the essential climate variables that has been already identified. And yeah, so now I will quickly go to results here. But before that, what are the links when we say rainfall and soil moisture variability? So if you see the Indian subcontinent, so rainfall that is received during the southwest monsoon season, it affects the evaporation, runoff, infiltration, and therefore the soil moisture also. In this schematic, if you see, so the amount of rainfall and how much is infiltrated deep, or how much resides in the upper levels, that only will determine the soil moisture. Of course, the texture and type of soil will be important, but ultimately the source of moisture comes from the precipitation, and we all know there are substantial seasonal and sub-seasonal variations in the rainfall. So it affects the soil moisture variability over the subcontinent. So these linkages play a key role in agrarian economy of the subcontinent, which is again home to billions of people, we all know. So in a typical case of drought or extreme floods, a lot of people get affected every year. So now here, if you see, this is the time series that is based on long-term observations. So it is now available from 1871 to 2022, but here it is only until 2020 we are showing. So if you see the red patches here, they show the deficit rainfall during the season, and the blue bars here show the excess rainfall seasons. And whenever you have the rainfall exceeding 10% or it is below 10% in negative side, so that is the typical cases of deficit, we say, or the excess that are linked to El Nino or La Nina. So we will be considering 2015 case of El Nino and the 2019 case of excess rainfall. So here we attempt to understand the spatial and temporal aspects of rainfall and soil moisture variability relationship during the recent two cases, as I already mentioned. So we will examine through this linkage in seasonal and subseasonal scales of fluctuations, along with the influence of dry and wet extremes within the season, how it affects the soil moisture memory. So these are data and resources. So already, if you see this GL- soil moisture, so studies have already shown that it is a good estimate of the soil moisture, which agrees well with the soil moisture observations. So Ganeshi et al. In their 2020 paper have shown in-depth analysis of this thing. And also we have, for precipitation, we use the IMD gridded data set. And the methodology which we adopt is we chose this rainfall and soil moisture variability over the core monsoon zone of India, which is again a region that better represents the all India rainfall, because the monsoon trough or the CTCZ or the intertropical convergence zone normally fluctuates around this zone. So we basically discuss our results through climatological anomaly analysis and then time series analysis, and using different statistical methods. So here, if you see the rainfall and surface soil moisture distribution, so this is a climatology based upon 1980 to 2020 data. So this is for rainfall, and this is for soil moisture. And again, if you see the seasonal anomaly for 2015 for rainfall and for the for soil moisture. So and this is seasonal anomaly for 2019 for rainfall, and it is for soil moisture. So you see there is a good correspondence between the seasonal anomaly in rainfall and the seasonal anomaly of soil moisture. Again, the same was seen during 2015 when the country as a whole received less rainfall, and the entire Indian region showed the soil moisture departures on the negative side. And now if you break the season in the active and break cycles during the monsoon, so the upper panel here is in the top left, if you see, it is 2015 daily standardized rainfall anomaly. And this is again the daily standardized surface soil moisture anomalies. And it is for 2019 in the bottom panel. So if you see here in the 2015 season, so there are very, the blue bars are on the positive side. If you see there are less frequent as compared to if you see what are below the zero line here. These are more frequent in 2015. Correspondingly, if you see in 2015, you see the persistence of soil moisture toward the deficit side. So whenever you got a persistence deficit spell of rainfall in 2015, so soil moisture displayed similar characteristics through deficit negative departures in the soil moisture. Whereas in the 2019, if you see the blue bars are quite frequent. That means you received good number of rain spells or even actives for which we consider 3 days or more continuous when the rainfall was above 1 standard deviation. So there also you see that frequently in 2019 we saw the more number of active cases, and the soil moisture remained on the positive side in the entire season. But one thing is, if we see this active and break patterns show that the dry spells red usually persisted longer than the wet or blue during 2015 and vice versa. So therefore, it is observed that the soil moistures evolve slowly. Even if you don't receive precipitation over a longer time, so soil moisture will slowly go into the state of deficit. And if you get continuously good rainfall, so it will take a longer time to build, but it will again persist longer. So that is where the soil moisture memory comes into picture. So following a persistent dry spell, even if it rains, slow buildup in soil moisture is seen, which indicates that more amount of rainfall is required to overcome the huge deficiency in soil moisture. It highlights the role of soil moisture in either way, memory in either way. Again, if you see the statistical distribution of daily soil moisture and rainfall anomalies over the core monsoon zone of India, so in the left hand panel, it is for rainfall anomaly in the 2015 and 2019, and in the right panel, if you see, that is surface soil moisture anomaly over the CMZ for 2015 and 2019. So again, in the rainfall anomaly, if you see in the 2015, the red curve you see, it is the peak is mostly towards the left of this mean line here. So most of the time the events were kind of skewed towards the negative side. So which means that the season as a whole experienced quite less rainy events. If you see now the 2019 cases, the tail as well as the mass of the spectrum moves towards the right. So which means that in 2019, we got frequent spells of rainfall as well as the intensity of rainfall was more. Now, if you see the corresponding distribution of the surface soil moisture anomaly, so you see this red patch.
You have 1 minute more.
Yeah. So I'm coming towards end. So you see that an interesting double peak you see in 2019. So which indicates that it takes more time for soil moisture to deplete when you continuously provide precipitation. So if we now do the wavelet analysis, so this is where we get very interesting results. So in 2015, you see the most of the daily rainfall anomalies show that the power was more concentrated into the high frequency modes. That is between let us say 8 to 16 days or so. There was not much transfer down towards in the longer periods of variability, and you see the peaks here it is again in the high frequency range. But if you see in 2019, there is the envelope goes right from the high frequency until the deeper zones where you see the period is getting transferred into the higher, low frequency modes. So there was nice transfer from rainfall to soil moisture if you see in the longer time scales, and it can be seen again with the single peak which we see in the power spectrum here. It is mostly in the 30 to 60 day mode. And again, same thing, we have broken it in the different time periods. So 2 to 10, 10 to 20, 30, 20 to 30, and 30 to 60. This is my last slide probably. So one thing which I want to highlight here is in 2015 and 2019, you just see this dotted lines show actually how much power, if it is the curve is above this dotted line, that means it is significant. So you just see when we go to low frequency modes, that is 20 to 30 or 30 to 60. First, you see this dotted line above that, which how much area of the curve is above that line, and also you see how much is the correspondence between soil moisture and this precipitation. So if you see this in 2019, there is a very good correspondence. The peak matches quite well as the substantial amount of curve is above this significant line. And in 30 to 60 days, there is a beautiful correspondence between soil moisture and precipitation. So which highlights that there is a significant amount of memory transfer in the soil moisture when you receive persistent spells of rainfall. But in 2015, you see most of the time the power was concentrated in the high frequency events. And again, this distribution, soil moisture memory, if you see for 2015 through autocorrelation analysis. So whenever these dots, you just track these dots and see where they are crossing this envelope. So it was mostly the soil moisture memory was like 26 or 27 days in 2015. But here in 2019, it exceeded beyond 30 and it went up to 34 or 35 days. So this indicates the contrasting influences of precipitation during the seasonal deficit or excess, which we have considered here for the case of 2015 and 2019 monsoon. And so these are my concluding remarks. So the climatology of rainfall and surface soil moisture, although they do not show exact one-to-one coherence when you see over a space in the subcontinent, but The anomalies are significantly coherent for the excess or deficit monsoon seasons, which we have considered here. So our statistical and time series analysis here suggests that the complex pattern of surface soil moisture and the rainfall variability is mostly dominated by rainfall fluctuations during excess monsoon year, but other variables might also influence that when there is less amount of rainfall, right? Now, whereas during the deficit year, the surface soil moisture or rainfall variability relation is less affected by rainfall variations, probably degree of non-linearity increases as the contribution of other factors which can influence soil moisture, it becomes important. And now the soil moisture persistent time was 27 days in 2015, that was deficit year, while it was found to be 34 days during excess year of 2019. Again, the open question is, in a warming environment, if we have increased variability of seasonal and subseasonal rainfall, it can potentially have a significant consequences on soil moisture variations. So these results we have already documented it, and it is under review in a journal. So with that, I will wind up my talk. Thank you very much.
Thank you very much, Dr. Bhupender. You can stop sharing your screen.
Yes, yes.
And questions will be at the end. So
thank you.
Yeah, thank you. So we can go for the next presentation, and the next presentation is by Dr. Samim SM Hassan Habib from Esparso, Bangladesh. So Dr. Habib is there? Dr. Habib present?
Yes, I'm here.
Thank you. Thank you so much. So your title of the paper is Interannual Variation of Rainfall Related to Low Pressure System over the northern and east coast of the Bay of Bengal. So
Yes.
please start. Yeah, thank you.
Thank you. Good afternoon, everyone. I am SM Hassan Habib from Bangladesh Space Research and Remote Sensing Organization. The title of my research is Interannual Variation of Rainfall Related to Low Pressure System over the north and east coast of the Bay of Bengal. I want to say something about the study area. Shading in this figure represents the elevation from sea level, and the area within this black box I only used for the detection of the genesis of low pressure system. That means the low pressure system, which are genesis within this black box area, are only accounted and used in further analysis. Climate of this study area is dominated by Indian summer monsoon, which stays from June to September. During this time, low pressure area developed over the India, and southwesterly wind carries the moisture towards the land and causes rainfall. Low pressure system is one of the major rainfall bearing phenomena during this monsoon season. So low pressure system is a low level cyclonic circulation of wind, which causes most of the rainfall, and one research explained about 60% of the heavy rainy days occur over Bangladesh due to this low pressure system. In contrary, this low pressure system is a major source of water for agriculture purposes, but excessive rainfall sometimes cause flooding and waterlogging. So it is certainly important to explore the relationship between this low pressure system and rainfall over Bangladesh in interannual time scale, because this will helps to understand and know the contribution of this low pressure system to the recent trend of rainfall over Bangladesh. So the purpose of the present study, first I want to reveal the interannual variation of this low pressure system, and then explore the interannual variation of rainfall related to this low pressure system. For the detection of this low pressure system, I use the GRE55 reanalysis dataset, and for rainfall, I use the FOG dataset. I use the method which is developed by Hasuzuka et al. 2014 for the detection of low pressure system. This method only detects the low pressure area as a low pressure system when it satisfies the three criteria. First one is a minimum 850 hectopascal geopotential height. then the cyclonic pressure will be present there, and this condition should stay at least 1 day. And after the detection, I classified this low pressure system into strong and weak on the basis of the relative vorticity. This is one typical example which I detected by this method. You can see the low pressure area is developed over the head of the Bay of Bengal and it propagates toward the northwest of India. Now the internal variation of the number of low pressure system. This black color represents the total number of low pressure system days, and this blue color indicates the strong low pressure system days. So you can see the low pressure system is decreasing as with the strong low pressure system, number of strong low pressure system days is decreasing. But weak low pressure system is not decreasing. But for the total number and strong low pressure system days, after the 1990s, we cannot say this is decreasing actually. This is not decreasing here. Now the rainfall with relation to low pressure system. This figure top left shading here represents the anomaly of strong LPSDS rainfall from the no LPSDS rainfall. We can see the over India and south coastal part of Bangladesh and Western Ghat is rainfall intensity is very high during strong low pressure days. Similar feature we can see for the weak low pressure days, but the rainfall intensity may be low, and for the coastal areas of Bangladesh, rainfall is absent. But this one is similar to the previous two figures, but for the no LPS days. You can see during this time, rainfall intensity high over the Meghalaya and south of Himalaya. Since this area over the Bangladesh, the southern part and the southeastern coastal part, I choose for the further analysis. Here, this figure shading here represents the trend of heavy rainy days rainfall rate. The heavy rainy days I identified using the rainfall greater than +1 standard deviation. You can see the rainfall over Bangladesh over which satisfy this value as increasing, but dotted indicate the which are statistically significant. So we chose these two parts. This part we can see the internal variation for the heavy rainy days of during the monsoon indicates the blue color, and this color is for the heavy rainy days related to strong low pressure system. We can see trend is not clear, but the internal variation is matched very nicely. And similar figure below one is explain the similar thing for the Chittagong Hill Tract area or eastern part of Bay of Bengal. So we can conclude the interannual variation of heavy rainy days rainfall rate during monsoon season is strongly regulated by the rainfall related to strong LPS days. So my conclusion, low pressure system is a major rainfall varying phenomenon for Indian subcontinent during monsoon season. Low pressure system does not show linear decreasing trend during the study period, and heavy rainy days rainfall rate over the coastal areas of Bangladesh controls by the strong LPS. Thank you for your attention.
Okay, thank you very much, Dr. Hassan, for a very interesting presentation. You can stop sharing your screen now, and we'll go for the next presentation. Okay, the next presentation is by Khan Mohammad Ghulam Rabbani. Mr. Rabbani, are you there? Mr. Rabbani, are you there?
Sir, I think Rabbani will also not join. So again, I'm just going to read out the abstract on behalf of Rabbani. So its title was Assessment of MPAS A. A is actually for atmosphere, MPAS atmosphere model against the WRF model results and observations in forecasting high impact weather events over Bangladesh. So what he has written is like this work documents the performances of model for prediction across scales, atmosphere, which is MPAS A, and the WRF model in forecasting selected high impact weather events over Bangladesh. three such thunderstorm events that occurred on 31st March of 2019, 17th May of 2019, and 20th May of 2021 were examined to evaluate the forecasting capability for each of the models. Now for MPAS-A, the model was integrated using a standard regional domain with 10-kilometer Voronoi meshes, and the WRF model was integrated using a regional domain of 10-kilometer horizontal grid spacings. In both cases, the model was run for a 24-hour time period using 3-hourly GFS dataset as the initial and latent boundary conditions on a 0.25 degree by 0.25 degree latitude longitude grid cells. The characteristics and intensity of the clouds were investigated based on INSAT 3D air satellite and Doppler weather radar observations. The spatial distributions of precipitation structure is compared against the observational data from NASA's GPM multi-satellite precipitation dataset. The lightning flashes were analyzed using the Earth Network Total Lightning Network and the NASA Lightning Imaging Sensor LIS dataset. The quantitative and qualitative results show that in most of the studied cases, there is a good agreement between observations and the model-based simulations. Performance diagram analysis were included to provide a better illustration of how simulations performed in predicting precipitation with some limitations, and the MPAS-A predicts precipitation better in terms of timing and area coverage. The findings of this study provide an important conclusion regarding the alternatives to the existing numerical models of the operational prediction system in Bangladesh and also for Northeast India. So that's all in his work, research. Unfortunately, we couldn't have him. So we can carry on with the session. As you can see, there are some questions for you in the chat.
Okay, thank you very much, Saurav, for reading out his abstract. In fact, his paper is really very, very interesting and very important. I wish he was there, but anyway. Yeah, so have you listed out the questions, Saurav?
Yes, sir. If I just quickly go through the questions for you. So the first question actually was for you. It's from Dr. Gitesh Vasan. He's asking that in your presentation, I'm reading out for him. In your presentation, okay, the annual and seasonal frequency of thunderstorm plots that you presented is based on which parameters?
Okay, well, Gitesh, are you there? Gitesh, you're not there, seems. Anyway, I saw his question on the chat box, and so I also replied to him already. And since he is not there to listen to my reply, so I can simply say that, well, those frequencies are actually based on the reports of the thunderstorms by the Surface Observatory of the IMD all over India. Okay, so it is actually based on the number of days of thunderstorms reported by the observatory. So that's the answer. Gitesh is not here, so we can go to the next question.
Dr. Gitesh is in the, I can see him in the participant list. Probably he's not around his PC or something like that.
Probably he is logged in, but he's moving around outside.
Probably, sir, probably. So yeah. We can move on to the next question. Is from Mohima Sultana Mimi. Miss Mohima Sultana Mimi is asking to Professor Kiguchi. I hope Professor Kiguchi is still there in the session. So she's asking, do ENSO or IOD have an impact on rainfall over Bangladesh, and how? Are there any relationships between rainfall and the Indo-Pacific warm pool over Bangladesh or in particular? So this is question for Professor Kiguchi. Professor Kiguchi, are you there? I don't see him in the list of participants. So we will just forward this question to Professor Kiguchi in email and get back to your answer. So the floor is actually open for the participants to ask. We have We have a fair amount of time left, so you can continue that discussion.
Yeah. So are there questions? Any questions by the participants? Seems everybody is silent.
Another question to Professor Kikuchi again. Do ENSO or IOD have an impact on rainfall over Bangladesh? I think that's that you can participate in this question. You can answer the question.
Whose question is that?
Do ENSO or IOD have an impact on rainfall over Bangladesh, and how?
So actually, I read that out. It's actually for Professor Kikuchi, and so as he's not.
I think.
So if you want to answer, you can answer. But Professor Kikuchi.
Sir,
well, yeah. I think, in my opinion, yes, it certainly has influence because the IOD as well as the ENSO has significant impact on the monsoon. Right, the ENSO years are generally correlated with the suppressed monsoon, whereas the La Nina years are generally correlated with the strong monsoon. So during the ENSO years, we have less rainfall, obviously, and so it also case with the IOD, the Indian Ocean Dipole. So both have significant impact on the monsoon system, the southwest monsoon system, our Indian subcontinent that includes Bangladesh, obviously. So that's a kind of overall answer to our question. Okay.
Sir, according to the schedule, we have another 10 minutes, maybe 10 minutes for concluding remarks.
Okay.
May I ask one small question, please?
Yes, Mohan. Yeah, please go ahead.
Okay, thank you. Very nicely conducted, and all those lectures is very fruitful, and some state-of-the-art technique is there. I would like to ask Ms. Shaila regarding the ROMS model validation. So I have observed that most of the validation is a bit not very close to the Bangladesh coastal border or in the northern Bay of Bengal. Is it because of the unavailability of data? That is my curiosity to Shaila, please.
Yeah, hello.
Yes, please.
Yeah, Dr. Mohan, thank you for your question. You can see that I have validated my model. This is spatial distribution. I have covered also the northern part. My study is from 10 degree north to 23. So I have covered all the area. And the validation that I have chosen the N4 data, I have compared my model output and for spatial distribution. Yeah, I have covered the coastal area also. The northern
it is
part.
there. I am asking regarding the observations from the ocean part. So it somehow covers the some observations or buoy data or others data, Rama buoys and others.
Yeah.
That belongs to Indian part. Yes,
yeah.
Right?
There are no buoy data. The northernmost buoy, only the 15 degree north Rama buoy data. So I do not have any available buoy data.
Exactly.
After that.
Yeah. So it may be a recommendation for Bangladeshi policymaker. There will be substantial ocean observation system for the northern part of the Bay of Bengal. It means who is very close to the Bangladesh territory. Yeah, that's the concern. Thank you very much.
Yeah. Thank you.
Okay, thank you, Dr. Mohan. So any other questions from the audience?
Thank you, sir. Sir, I'm Wing Commander Monjila from Bangladesh Air Force. I have one question for SM Hassan Habib about interannual variation of rainfall related to low pressure system over the north and east coast of Bay of Bengal. The topic is very interesting because I think it will be very important, that is helpful forecasting tool. We are frequently we have to give forecast of rainfall. So my question is how, maybe I missed, maybe Mr. Hassan explained, how he defined the strong low pressure system and weak low pressure system, because in the concluding remark that he concluded that the strong low pressure system cause rainfall during monsoon season over northern coast and eastern coast. So as Bangladesh in the northern coast of Bay of Bengal, so may I know again, clarify the defining of low pressure system, weak low pressure system and a strong low pressure system.
Thank you for your question. May I answer?
Sure,
Yes.
please.
Yeah, go ahead.
Okay. I want to share my slide again.
Oh, I see. Okay.
You want to know about the classification, how I can classify weak and strong, yes? So I use the value of relative vorticity, which is greater than this value. Can you see my slide?
Yeah.
Yes.
Last sentence. The relative vorticity of the LPSs, which I detected, the value greater than this value are classified as a strong LPS. And these strong LPS, you can see here, the rainfall over Bangladesh, actually the southern part and coastal part are mostly affected by high or heavy rainfall. The intensity is high, and the color shading here is only for the which area are statistically significantly high. Okay, so this one you can see the intensity of the rainfall is not statistically significant result over southern coast of Bangladesh. You can see here, but over the Chittagong Hill Trace, northern part is maybe rainfall rate is low.
So actually it depends on the location of the low pressure system.
Yes, this
that
is
where it located.
This is also important, but I classified the only strong and weak. So we can say, but we can guess that the weak low pressure system is location is mainly southwestern side, or when it was generated, maybe that time it was weak, but after a few days maybe it is stronger. Okay, so maybe this is one reason. So the rainfall distribution is related to the strong and weak also, not only the location. Or location may be influenced by the genesis time or the decaying time. Am I clear to you?
Yes, actually, since I want to take your paper or take as a forecasting tool, that's why I want to be more clear about this thing. Yes, may I know that your study, the low pressure system, did you consider that month of formation? Because depending on the wind direction, like a low pressure system formed in the month of July, it will create give rain in some location depending on wind direction also. So did you consider month or whole monsoon season?
Actually, for this research, I used the monsoon season, but I analyzed for the March to November.
Mainly March to November.
You can see my slide. Yeah. So June, yes, please.
As per your study, that the frequency of strong low pressure system is more in the month of August. Okay.
It's different from other 3 months, but for week one is August and September is same, but the strong one is statistically high in August.
Okay. I'm really interested in this topic, so I'll be very happy if I read in future in deeply this thing. Thank you.
Thank you very
I was
much.
happy. Thank you.
There are two more questions, I think, both to Dr. Bhupender Singh. One is from, I think, Mohima. She just wrote something on the chat box. And the other is from Dr. Torut Rao, Professor Torut Rao. So Mohima is asking that, Dr. Bhupender, are you hearing?
Yes, yes, sir, I'm there.
Okay, great. Yeah, you can probably also read the question. What
Yeah.
were the reasons behind the excessive rainfall in 2019? That is the
Yeah,
question.
so one of the prominent reasons was the conditions in the Indian Ocean, that was like the positive Indian Ocean dipole conditions that favored the excess monsoon in 2019. If you recall, if you see the month-wise evolution of rainfall in 2019, so during the initial phase of the monsoon in the month of June and maybe in the July, so rainfall was more or less normal or below normal. But as the season progressed and the influences of the IOD became prominent, so during August and September, if you see, it was quite well above the normal. So overall, when you incorporate the later part of the monsoon, the August and the September, so you see that the season received the excess amount of rainfall in 2019. Yes.
Okay, thank you. Then you have got one more question from Professor Terao.
Yeah, so he is asking, can we detect any significant time lag between soil moisture and precipitation? This is interesting question. Actually, we were trying to study this part also. So when we saw the lead lag correlations in the soil moisture and precipitation over the core monsoon of zone of India, so what we saw that the zero lag correlation was maximum. So if you are having good amount of precipitation, so soil moisture responds instantly. But if the spell persists over a longer time, so evolution of the soil moisture for a longer duration takes time. Okay, so it is if the rainfall spell is persisting and the amount of rainfall is substantial, so soil moisture will respond immediately. I mean the coherence will be more. But if the spells are of low intensity and there is breaks and then other and after some time it is active spells, so at that time the correlation drops and maybe you can see a slower response of soil moisture to the precipitation received.
Is that okay, Professor Terao? Are you there? You can directly also interact, live interaction. Professor Terao, I think you must be there because you have to chair the next session.
So is it okay, Dr. Terao?
Yeah, okay, thank you. So maybe, so it depends on some sort of interaction may different for these,
yes.
some different region may have some different characteristics.
Yes,
so
yes, of course.
Information. So maybe we can use that the laboratory analysis to detect the difference of the trees. So we may proceed.
Absolutely.
Thank you.
Yeah, thank you.
Any other question? I have one or two questions. One for Professor Murata-san. Are you there?
Oh, thank you. Yes, I'm here.
I have a query for you. In your presentation, you mentioned that you use some reliability flag, right? Reliability flag.
Yes.
What is that reliability flag?
Yeah, so GSMAP using the several microwave sensor satellite on board, and it's when the reliability flag is low, the satellite didn't pass near the observation area. So unfortunately, 14th June, there was very less satellite passing near the observation site, so the reliability flag was low. Yeah, so that's why. So we couldn't get good data.
I see. Well, one more question to you, Murata-san.
Oh, yeah. Okay.
Yeah. Okay.
Thank you so much.
A very interesting presentation you have made, because I know that you have got a long time series of observation using very special instrumentation our Meghalaya area, especially the Cherrapunji, etc. But you also mentioned that the Bangladesh Air Force radar failed to capture the rainfall on 15th June.
Yeah.
Which Bangladesh radar you used, the airport radar you used for that?
So it's a observation site of Bangladesh Air Force radar was little bit far from Cherrapunji. So
Yeah, but I think they have got 2-3 radars, right? I think there is someone from the Air Force, Manjila is one. So there are, I think, more than one radar of the Bangladesh Air Force around Bangladesh.
yes, maybe near Chittagong side. Chittagong.
Oh, yes. Thank you very much for taking interest in Bangladesh Air Force radar. I'm really happy to know this, that you are using or observing our radar. Okay, our radar actually, most of the time, it works in plane position indicator, and range is around, effective range is around 400 kilometers. So yes, most of the time, our Chittagong radar, it fails to capture the rain of northeastern part, that is Sylhet and beyond. That's why maybe it is missed, but our within effective range, our radar is capturing fine. We are basically we are using our radar observation for flying purpose of flying, since we are from Air Force, that's why. So most of the time within 300 kilometer or 350 and 400 kilometer radial, this radar able to capture the rain bearing cloud, but beyond 400 kilometer it fails most of the time.
Because I understand you have got 2-3 radars. One is in Jessore, other is in Chittagong. Also
Chittagong.
someone, I think one in the northeastern part, Sylhet or Rangpur.
No, in Air Force, BF doesn't have any radar from in Sylhet and northeastern part. In Sylhet and also in Rangpur, we only have one Jessore, that is southwestern part of Bangladesh, and southeastern part of Bangladesh over Chittagong.
I see,
Oh,
I see.
so you have got only 2 radars of the airport.
Yes, yes.
Oh, I see. Well.
But nice to know that people are taking interest in BF radar. That's good.
Yeah, you know, because one of the Bangladesh airports, a student is working with me, Rehan, for his MSc thesis.
Oh, yes.
His MSc thesis. So he's using his Jessore radar data for his thesis. So that's why I was also interested to know about that. But, but anyway, thank you so much for clarification. But Murata-san, you could have used the BMD radar, no? BMD has radar in Morbi Bazar and also in.
But yeah, BMD data is very excellent because they're operating continuously. So until now, BMD radar is not continuous. That's a very big problem for us.
Yes, we'll be very happy actually if BMD starts to share radar data continuously with us, because BMD has very good radars, very good radar. But very
well, Dr.
not
Bhuya can
frequent.
respond.
Yes.
I think Dr.
Thank you, sir. Actually, this out of 5 radars, all 5 radars are very old, and as you know that one radar's life is only 15 years, but these 2 radars, Cox's Bazar and Khepupara, already more than 20 years already gone. So BMD is going to replace all the radars, and Dhaka radar and Rangpur radar replacement is going on. Process is going on. Maybe next year we'll get the new radar data, and the process to replace the another 3 radars like Khepupara, Cox's Bazar, and Molvi Bazar. Maybe it will take some time, but Khepupara and Cox's Bazar we are going to replace with Japanese project, JICA project radar. So at this moment, the situation radar echo is not very good, but we hope that after install new radar, we will continue the 24 hours.
Yeah. It's very nice.
So anyway, thank you so much. But to cover the the excess rainfall over Meghalaya, you could also use the IMD radar. At Cherrapunji itself, there is a radar of the ISRO at IMD, right? And then there are so many other radars. Agartala radar is there. Kolkata radar is there, right?
Yes, once upon a time, we used the BF person actually. We used the Agartala radar observation because this observation very helpful for us for taking decision. Yes.
Yeah, and right in Cherrapunji itself, there is a radar.
Yes. Unfortunately, the radar, the Cherrapunji radar is now in maintenance.
That is a whole story. Well, on the very crucial time, on the crucial day, the radar is on maintenance.
Yeah, but now we can get good research for using radars. Yeah, we hope the future work.
Yeah, because in that area, this is a very important area for many things, for very high rainfall as well as for the systems, convective storms. So there are a lot of radars. I mean, if we just include all the radars of India as well as Bangladesh, then that entire area is well covered by the network of the Doppler radars. See, I mean, all around, we have got at least 4 or 5 radars of IMD itself, and then the BMD radar also coming up. Molvi Bazar radar, I think, was the most recent one compared to their other radars. Because when I was there in 2010, the Molvi Bazar radar was getting commissioned, if I remember correctly. So it was just 10, 12 years old. But in any case, if we have the radar at Rangpur and Molvi Bazar and already the existing radar of Cherrapunji and Agartala, and also further in the Assam region, there is a radar at Mohanbadi. Mohanbadi radar also in a very high mountain terrain region. And then Kolkata radar covers almost all of the Bangladesh, covered by the Kolkata radar as well as Agartala radar. Right. So having so many radars around that, I hope that we should not miss any important system. Right. Even if there is a maintenance of one radar, I hope the other radars will function in that area. Right.
Yes. Yeah.
So right. Okay. So any other question, or we have to wind up? I think right. Already. What is the time now? About 10 to 4. No, we have got session up to 4:20, right? The current session is supposed to continue.
Yes, you are supposed to continue for at least another 11 minutes.
Okay, great. So we can continue the discussion on this session, or we can summarize the session.
I think it's better if you just summarize the session.
Okay, so we can summarize the session in that case. Thank you, Saurabh. Well, I see that there were about 6-7 presentations listed for this session, out of which 2 speakers were not present. So among those who were present, well, I was one of the speakers in the beginning, and I hope that I don't have to summarize my talk, although, kind of I presented about the severe storms in the changing climate scenario, speculations, uncertainties, and realities. Now, see, I have always a kind of a concern that everything that happens in weather and climate area, people start trying to blame the climate change for that. Well, climate change is definitely a reality. It is occurring, but there are many things which need not be because of the climate change itself. The atmosphere, there are so many things which keep changing frequently because of the anomalies, transient features keep coming. So the present models, whether it is a NWP model or the climate model, they should be able to provide good forecast of any extreme weather system, provided, of course, our observation systems including the ground-based as well as the system. This will be able to capture all the observations. So if so, then we should be able to give a good forecast for the systems, any upcoming systems. Then there was a presentation by Professor Kikuchi about the data rescue. And of course, they have done a marvelous job along with Professor Hayashi. They tried to rescue 100 years of rainfall data by actually sitting at IITM Pune. The old records, you can just imagine how the data could be in the 100 years ago. They were in all, and they were written in a register, and then they could physically go and retrieve those data. So it's really a very, very, very good attempt. But there are also some good report that they found out, like, as I understand, Professor Kikuchi is not here, although I understand from his presentation that from his analysis of the rescued data, it seems that he found that there is an increase in the trend of the light rainfall, but there is not so significant increase or significant change in the heavy rainfall, like 50 millimeter or so. So that's what I understand from his presentation. Then the next presentation was from Dr. Saila Akhtar from Bangladesh Betar Information and Broadcasting. Well, she had made a very good presentation on oceanic response to cyclone Amphan. Okay, it was really very interesting presentation, and she used a high resolution MOMS model, ocean model, to simulate some of the parameters for the cyclone Amphan, and she could capture interesting results along with the track of the cyclone, especially which showed there was a cooling along the track of the cyclone, and which matched with the observations of the nearby buoy data, like the Rama buoy and other Argo reports. So there was a very interesting presentation by Dr. Saila Akhtar. Then the next presentation was by Dr. Murata-san. Of course, it was very, very interesting, and she presented a heavy rainfall episode case between 14th to 16th June 2022. I mean, really interesting case, and according to her analysis and observation, the rainfall that occurred during that period exceeded all the past historical record. In one day, the rainfall was 1,003.6 millimeter in 24 hours at Mosim Ram near Cherrapunji. It was really a historical record. And in 3 days' time, from 14th to 16th June, she found that the rainfall exceeded about 2,500 millimeter. Really, really very good. And I really appreciate their hard work, which is going on for many, many years. The team has been visiting Bangladesh for, I think, more than 30 years or so, almost since the early 90s, and they've been taking the rainfall observations, keeping the rainfall records, also trying to install many interesting instruments like distrophometer and automatic weather stations, etc. in that area. So thank you very much, Professor Murata-san, for presenting this very interesting case of high rainfall, which broke the historical record. Then the next presentation was by Dr. Bhupender and his team, including Dr. Majumdar, very, very good worker, very good scientist, working at IIT on the soil moisture area. And I think he presented a very, very good result, very interesting result about the relationship between the rainfall and the soil moisture, especially during the deficit monsoon season. I had a query, but I did not ask him. Well, my query was that since the soil moisture is getting measured every day, I hope so, it is every day, then whether we are using that soil moisture data in the NWP models of the IITM or the climate models, I don't know. Anyway, I can find out directly from Dr. Majumdar later on. But the land data assimilation system is very, very important part of the modeling system, which assimilates all the soil moisture data based upon the satellite observations as well as the in situ ground observations. So that's very, very important. Then, of course, the next presentation was by Dr. Hassan Habib from Sparso. And there was a good discussion on his paper presentation, especially the interannual variability of the rainfall related to the low pressure systems over the Bay of Bengal. Well, whenever there is a passage of the low pressure system over the Bay of Bengal, it produces good rainfall around the Bangladesh as well as the northeastern part of India, West Bengal, and so on. Of late, people have been saying that somehow the number of low pressure systems have increased, whereas the number of depressions have decreased. Again, people start correlating that with the climate change and blah, 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 that somehow the depressions which used to form 20, 30 years ago, the number of depressions which used to form 20, 30 years ago are not forming that much nowadays, and they just remain as a low pressure system. But it is very important to track the low pressure system because that provide very good amount of rainfall. And of course, our models are capable enough. All the NWB models, especially in the shorter range, as well as up to 7 days period, the models are capable enough to predict, in fact, monitor the formation of the low pressure system and also the monitor its passage, its track, and also the rainfall amount. So that way is very, very, very good. Then, of course, I think there was the last presentation. Of course, the last one was by Ravani, but Ravani was not there. Although his presentation, I would have really liked it because he tried to work on the MPAS, the model across, model prediction across scales, which is, the next generation of the WRF model. And MPAS model is still under development. Compared to WRF, although I think it started almost 10 years ago. WRF started sometime back in 2002, 2003, but MPAS started sometime around 2009, 2010, and still under development. And many features of the WRF, the developers of the MPAS at NCAR, they're trying to get into the MPAS model. And the advantage of that model is that you can zoom the area of your interest and have high resolution in that area and coarser resolution in the other area. So that is very, very important. So with this, I think that's all. That are the presentations made in this session. It was a really, very interesting session because climate extremes everybody is interested in, and everybody is also impacted by the climate extremes. So it was very important and very interesting. So thank you so much all, and I would hand over to Dr. Bhuiyan for his remarks, our co-chair for this session. Dr. Bhuiyan, please.
Thank you, sir. Thank you very much. Actually, I should start with your last sentence that extreme events frequency and intensity is increasing day by day, and we are the victim of the climate change. So our research and research activity in this sector should increase, and Dhaka University Meteorology Department is trying to continue this type of research, and they're continuing this type of international seminar every year. So I think lots of findings, lots of innovative research will come out, and that will help us a lot for the, especially for the operational meteorologist. We can use this type of research tool for the forecast. And also, I would like to say that the impact-based forecast is our National Meteorological Service target. Not only the forecast, but impact-based forecast in different sector. So we will work together, and in near future we'll looking forward for the sustainable development. Thank you, sir.
Thank you, Dr. Bhuiyan. I think we have completed the entire session on time. I was a little worried because I took myself a lot of time, more than the allotted time. But anyway, the overall session could complete just right on time. So we are really happy for that. And I thank you. I thank the organizers a lot for giving me this opportunity to chair this session, and also for organizing this conference, annual conference. I think they have been doing since last 3 years. This is the third year, right? Saurabh, I guess. And
Yes,
so
sir. This is the third one.
third one, yeah.
Basically, the fourth one in 3 years.
Oh, right. So very good. In fact, the Department of Meteorology is doing wonders, under the chairmanship of Professor Tawhid Rashid, who is really, really very dynamic, very hardworking, and doing really great things, especially by establishing the satellite Earth station and also motivating the students, also collaborating now with the international organizations. Is really doing very, very excellent job. So we'd like to thank Professor Tawhid Rashid especially, and the entire team, which I know, how much it takes to organize a conference like this. It takes months and months of work together, and especially when people don't respond, you keep requesting, you keep writing the emails and people don't respond, right? So you have to have really patience to get the answer, and then they could succeed in bringing very good papers for this conference. And we are looking forward to great presentations in the coming days. Tomorrow, I think it is for 3 days, right? There was some panel, everything. Plenary session also kept, I think, after 2-3 days. I don't know why there was a break.
Yes, sir. The plenary session is on 15th, Thursday.
Yeah. So there was a gap between the regular session and the plenary session. So for some reason, maybe some important speakers may be available on that day only. So that's why.
We actually want you to grasp in all the talk that will be given in the second these 2 days. So we want to make it an impact. That's why we're planning it for after just a brief break.
Okay.
This is how we want to plan it.
Oh, I see. So you wanted some time to summarize, wind up all the things and summarize into a very good recommendation, probably, right? So, okay. So I think nothing from my side, and if something is to be there from Dr. Bhagyan as well, otherwise we can hand over the floor to the organizers.
Thank you, sir. Thank you, all the participants, and also both session chair and co-chair. So we conclude our technical session 1. Our next technical session 2A, which will be impacts and challenges of climate change. So it's about 22 minutes to go. So you can grab a nice cup of coffee because it's mostly here it's in afternoon. So see you there in 20 minutes time. Thank you. Thank you again.
Thank you very much.
Thank you, sir. Thank you, everyone.
Thank you very much.